Hello, everybody. I'm Mark Himmelstein. I'm the Chief Technology Officer for RISC-V International, and I'm here to talk about how to work with us. So this is kind of a nerd's guide and navigating. I'm sharing this presentation with Stefano and Jeffro, you guys may know, who are going to help present the slides. And why don't we get started? So the agenda is pretty simple. What do we do? Who we are, the life cycle of extensions, the roadmap, the rules of the road, sort of a working groups guide, including all the tools, and then what you can do in some Q&A. And as always, we're a community. So if you see something that you think that we could do better, please help us do that. So what do we do and what do we don't do? So this covers, so what we do within the technical world is we cover the technical aspects of RISC-V International. We develop the instruction set architecture, specifications, formal model, the rules for developing the ISA. So there's a lot of conventions we have to do in order to make sure that, that we work together well. Developing the implementation, independent stuff. So think of the ISA as an iceberg. The stuff that you see, instructions and control status registers, they're the top. They're what you see. The formal model, they're what you see. But the biggest part is really underneath, and that's the ecosystem, which is predominantly software. So things like operating systems, hypervisors, bootloaders, config databases in the proms, other tool chain things like profilers and debuggers and so on and so forth, and the libraries and runtimes for the applications, as well as applications where appropriate. So we have this thing called horizontals, and what they really are attributes. So we have a bunch of things that fall under this category, and we take a look at every extension we do and see what we have to do in order to accommodate those attributes and make sure that we're dotting our I's, crossing our T's. So we can't go ahead and release something without the security team working with the extension team to make sure that there are no exposures for our members. We also work with other nonprofit organizations. Some of them are listed here. And the idea is we coordinate with them, we enable them where possible, we break through, roadblocks, we work together to promote things. So there's even a bigger ecosystem than just the things I spoke about. Places like Open Hardware have reference designs and so on and so forth. And then obviously the idea in the end is for our commercial members to go ahead and make money. And so all the things that it takes for them to make money, including creating products and creating the commercial pieces that people use to create products, and also to do commercial versions of some of the open source things that we do inside of RISC-V. So for example, compilers, we have a number of compiler vendors who specialize in various areas, and we do GCC and LLVM, but we work with them to enable them to do the rest. What don't we do? Well, there are standards that are outside of RISC-V that need to be there. And one of them that happened recently is overlays. There's a lot of implementations of overlays in various places, but there's no standard out there. So the overlay people wanted to put something together, and we said, sure, you can do that, but you got to create it as a standard that stands independent of RISC-V. So we'll enable that. We'll make sure that it gets into its own project eventually. We're hosting it at the moment, we're incubating it, and we're very glad to see that occur. We actually don't do the implementation pieces. So we do not do soft or hard chips, so FPGAs or discrete chips. We don't do any of that stuff. We don't do the DV that comes with it. We expect that other people are going to do it, but we enable it. We go ahead and do things like simulators because they're really implementation independent in their purest form. I mean, you can make things that are implementation dependent there, but in general, simulators are independent of a particular implementation. So therefore we support and we develop those things with our members. The other thing is that all those things that have places and projects that live outside of RISC-V obviously are the real repositories for those things. And although people develop them under the umbrella of RISC-V, the idea is that they upstream them later on. And then again, very clearly, we don't work on commercial products. We don't sell anything. We want our members to sell things, and we're non-denominational there. And we do have a RISC-V website that has a thing called Exchange, and anybody who's got a product that's based on RISC-V is allowed to go ahead and publish information about that product and how to get to their websites and buy that product. So who's who? So look, there are some people that I'm going to introduce here. They aren't always on the phone with us, so I'm not going to actually show you pictures of them or anything. But we have a very small staff. Callista is my boss. She's the CEO. She runs the board of directors. She is not the chairman of the board. I'm Mark Himmelstein. I'm the CTO. I chair the tech chairs meeting, and I actually run some of the technical steering committee meetings, but I, again, am not the chair. Kim McMahon is the director of marketing, and Jeffro and Stefano, who are helping make this presentation, are half-time on our project as technical program managers. We have some technical group leaders. The technical steering committee, TSC stands for Technical Steering Committee, is run by Yunsip and by Charlie, who's it's actually vice chair, not co-chair. that naming has changed over time. And then Krista, who is kind of the godfather of RISC-V, and he's our overall advisor, and he helps keep us on the path of his vision to make this a product that can last for 50 years. And then we have community representatives on the board, Ken Doxer, who's been very active in our world of both writing policies and being chairs of things. He's the chair of the bit manipulation extension. Richard Bond from Seagate, also very active. His team has been very active. Dr. Bao from Chinese Academy of Sciences. They have been very, very active in helping us out. Stefan, who's helping us out with our relationships with academia. We're working on a seeding program to get boards into academia with RISC-V processors, and Jesus, who's leading up the supercomputer efforts. So what does the organization look like? Well, there is the board of directors, and then underneath that is the technical steering committee. Okay, and it's responsible for a lot of things. We put here architectural profiles. So this is like, like something like ARMv8. We have RVA19, that's the application stuff that was ratified in 2019. There'll be one for 21 and so on and so forth. And then my office, and I help run a bunch of these things, coordinate a bunch of these things, make sure there aren't gaps, make sure there are resources, and make sure that technically we're talking to each other and we're doing something that's consistent and coherent. From there, we have ISA committees. So one is the unpriv, so unprivileged instructions, and the other is priv. The green boxes are things that are done. And so we have a bunch of task groups that are outstanding here that just work on extensions. Then we have these horizontals. And again, these are things that go across all the extensions. So again, we'll pick on security. If you're going ahead and doing bit manipulation or vector, you better talk to security people and make sure you're not creating any side channel attacks or anything like that. We have the cache management operations group. We just got to work with them very closely, given all the fancy break-ins of the last 10 or 15 years. But each one of these has to sign off on those extensions to make sure that we have done the things that we need to do to provide a robust extension to our members. They also can go ahead and put together their own specifications. They're just not ISA specifications. So for example, the software group's responsible for all the binary interfaces, so ABI, SBI, etc. We also have this verticals group, which is just starting up. So it's all in red, pending, and it's starting up as an interest group. But the idea is to get various industries in and tell us, whether we're covering their gaps, whether there are other things we should look at. And so we're trying to get them involved. It's kind of like inbound product management. And we've just kicked that off. We're doing some some polls right now, and then we're going to drag in some of the industries, and hopefully we'll use that to affect both the extensions that are in flight as well as the Nexus extensions that we do. So I'm going to go into a little bit about technical governance. So the TSC sets a strategic direction. We have a little meeting on the side, which goes ahead and does the strategy. And I apologize, some of the nomenclature hasn't been updated, but this SEs are really, they're the ICs and the HCs. So the ISA committees and the horizontal committees, and they make their own local strategy. They launch task groups in order to meet the goals that are set by the TSC. And exceptions go back to the TSC. So we changed some of the names recently just to make them reflect more of what we're actually doing. And so if we go back to this picture, again, the UnPriv IC and the Priv IC, so those are the ISA committees, used to be called standing committees, are now called ISA committees. And then the horizontal committees also were standing committees. So we differentiated them. And so I'm sorry for the little late last moment name changing, but I thought I'd explain why we did it. And that actually is useful for you to understand what kind of evolution we've made in describing the organization and making it make sense and do the things that we want to do from a higher level and outside view perspective. So the next thing I want to talk about is the extension lifecycle. So all of a sudden you decide, hey, I want to do an new extension. I want to do bit manipulation. What do I have to do in order to get that off the ground? Well, we have a beginning cycle. So there's inception where we say, hey, this is something we want to do. And then what we do is we get an acting chair in place, and they put together a package that goes to the technical steering committee with things like the description, the charter, the deliverables, and then nominations for the permanent chair and vice chair. And then a final charter is laid down once that team is in place. So that team is a task group. That task group goes ahead and works on the specification. We have a bunch of milestones that you see on the milestone line there. The first is kickoff. That's where the group's created. And then stable is where things are really not going to change after that. They're just going to get cleaned up in order to go to public review. The freeze is where we actually freeze the spec and it goes to public review. The intent is for it not to change. We know reality isn't that. So there are checkpoints in between the freeze and the vote ready that people can do if there's some changes. But if people are doing major changes, then we throw them back into the development cycle and start over again. During the period of between the freeze and the ratification vote, there's a bunch of work that needs to be done. And so we've created this thing called the definition of done. And so when you see the word done tasks, those are things like getting the compiler work done or getting the formal model done or the architectural work. And we've set guidelines for each of these milestones about what needs to be done on each one. And you'll see that in a minute. And then finally, when everything's ready and then we get sign off from the horizontal committees, we go for ratification. And then the ratification occurs at the technical steering committee level. The technical steering committee is made up of members that are considered premier members. And there's different levels of membership, as well as the chairs of the ICs and the HCs, so the ISA committees and the horizontal committees. Sometimes things don't totally get done by the time we do a vote. And so we can't allow people to ask for a waiver, and then some work could happen afterwards. So for example, if there's more optimizations that should have been done, but we couldn't get to them by the time of ratification, we can do them after ratification, and that's why we have the complete milestone. If you go ahead and decide that you, after you've ratified something, that you want to go ahead and change something, we do not rev the extensions. Instead, we say you have to create a new extension because we want to make sure that people can depend on the extensions that we ratify to build their products with. And if we're changing them, that's not good. If we add new ones in, they can choose whether to adopt those or not. And then again, we put these profiles together So we'll have something like RVA21, which is the application profile for 2021, and it will have the list of extensions that are supported, optional, and unsupported, and we'll collect the things that are ratified at that point that are appropriate. So this is the definition of done checklist. It's a bit of an eye chart, sorry about that. But as you can see, we've broken this down by the milestones. So stable, freeze, the optional ones, when it's vote ready, when it's complete. And the teams have put together what they think need to be done in each of the arenas by each of the milestones. And this is the default. And if a task group wants to change this, they have to ask for exceptions. But you can see this is meant to be very complete. So all that stuff I talked about in the bottom of the iceberg, the ecosystem, that's a majority of what's here. The stuff that has to be done by the freeze, those are things that we talked are really kind of on the above the water. And so there's just a lot of stuff that needs to be done here. And we've worked very hard to work with our members to get it done. Our attempt is to really have sort of the same kind of contributor model as Linux or Hadoop or Apache. And then we also have engaged some large organizations and institutes around the world who take on some major pieces like architectural tests or compiler work. So we also define before and after each milestone what needs to be done. And I'm not going to go through them here, but just know that we've gotten very specific about what needs to be done at each time or after each time, so everybody knows what their job is and what they need to do in order to get to the next stage. All right, and now I'm going to go through the roadmap a little bit. I'm just going to talk about some of the high priority items. It's not the complete list. This is just some that have major visibility, and then I'll show up kind of the eye chart of the complete list, just so you can see that there's a lot of things in flight. So these right now are our high priority items. So bit manipulation, I think you understand. Those instructions have been around for a long time. Crypto, in fact, is crypto scalar. So we broke it into crypto scalar and crypto vector. And the crypto scalar stuff is a high priority, and that's working on getting done. And then platforms and profiles. So this is the platform that is, headed towards Linux. So when we talk to a distro and we say, look, this is what you need to do, it will include a profile, so RVA19, and it will have a set of ABIs and device tree and whatever else needs to be there. And that will be considered a platform. And that will be like risc-v.org/Linux/v1 or something like that. We haven't picked the names yet. And then that's a fairly big thing, and it has just started. So the freeze is kind of out into Q2 next year. But we hope to get things to a point where people know where we're going fairly quickly. Vector, very exciting. We are doing some rocket science there. We believe it is very exciting, and we're hoping to go to freeze this quarter and vote next quarter. There's a lot of work to be done there. And again, we're asking for help, and we've gotten help from a lot of people. If you're interested in helping, feel free to contact us, help@risc-v.org. We're glad to get anybody who's interested. And then the PACT SIMD stuff, this has been worked on for quite a while. It's close to the end, and it is a very big thing for embedded and for small footprint kind of worlds. Everything from machine learning to other workloads. And then finally, virtual memory, where again, we've been working on this for quite a while. We're working trying to get it over the finish line here so that we can go ahead and make that available to the world, and they can model their virtual memory after that, and then we can have more compatibility from implementation to implementation at the operating system level. This is just an eye chart. I'm not going to go through it. These are a bunch of the other extensions we're working on. As you can see, we have roadmaps for these things. They are not low priority, but they're not the highest. And so when we have resource contention, we throw it at the highest items that we agree are the highest items. And then the others, we have to make way for them with resources. So next, rules of the road. So we have to go ahead and have some policies, procedures in place. And so we've created this set of rules. And the first one is about the code of conduct. And we do have a code of conduct link at our website. We are welcoming to everybody. It's not just, we're not trying to just stop illegal behavior. We're trying to make this a welcoming environment. We are trying to make sure that people are respected, that everybody gets a chance to say their opinions. I mean, we can't honor everybody's opinions. Like sometimes you have to make a decision, but we try to do that respectfully, and we encourage our people to do that respectfully. We have a zero tolerance policy, and when something comes up, we work it out. A little bit about nomenclature. So we have this thing called profiles I've alluded to before. We have RVA 19, and that is the versions of the things that were ratified in 2019 for 32-bit or 64-bit, or more generally, RVA 19, which means both. And that's at the application level. And RVM is more at the microarchitecture level, microcontroller level. And so, so that's really bare metal. And so, we have both of those. We may add some later on. The technical steering committee goes ahead and decides when we go ahead and do a new one. There is unlikely to be one in 2020 because we're still in the process of ratifying some of these very big extensions, but there will be one in 2021. And then the platforms we're working on, again, are things like in Linux targeted ones. So we can go to Red Hat and Ubuntu and SUSE and Debian and tell them, look, go towards this. They don't like lots of variation. So we're hoping to get them on something that all the members agree to are a good target. So we do have some policies. They codify things. They include things like rationale, what the policy is, transition, exception handling. And then we review them by our tech chairs group, which is all the chairs of the ISA committees, the horizontal committees, the task groups, and the interest groups. And then the last thing is we can't, premeditate everything. I mean, we do our best to get something laid down so we have conventions so we can work together, but we are a continuous improvement organization. So just like I said on the first slide, if something isn't sitting right with you, help us make it better. I mean, that's what we're about. We're a community. So there's some basics here. Definition of done, I talked about it a little bit before. It was a very clear thing we needed. When we started taking a look at the roadmap, we realized we hadn't agreed as to what it meant to be finished. And that was the first thing we did. We have a whole bunch of administrative ones. One example is group creation and chair approval. So how does that get done? And so we write those things down so everybody knows what the process is, and we can all do the same thing. And then how we work. So there's a bunch of things when you're actually creating the extensions. What do you do? Where do you put it? What does the documentation look like? Rationale, instruction encoding, so on and so forth. One of the interesting things here is we also have a fast track. So for very small things, we work very hard to not have this very long extension lifecycle you saw before. There's a shortened version of them for small things. We can't shorten the public review cycle, but we can shorten everything else and make things go more in parallel. Okay, that's it for me. I'm going to hand it off to Jeffro and Stefano. Thank you very much, and I'll be back at the end for questions and answers.
Thank you, Mark. My name is Jeffro. I'm a program manager with RISC-V. I work half-time on technical projects and half-time on non-technical administrative projects. And we're here to talk about the RISC-V working groups and how we enable them to get the things done that they need to get done. So let's dive in and figure out where we can start. The general starting point that we always like to recommend to people is to start at the website, risc5.org or riscv.org. That's a great portal for finding anything that you need to know about RISC-V. There's also the Exchange that Mark talked about earlier. The Exchange is it's a listing of our ecosystem. It shows all of the boards and SOCs that anybody can contribute to. And we also have a feature on the Exchange front page that shows all of the available boards, available hardware, so that you can take a look. The RISC-V community is that's a section on the website that provides a lot of learning materials as well as guides, a guide to how to use the member portal. The member portal is our set of mailing lists where all of the working groups are get all their work done. The news feeds are on the website. That's all of the news from RISC-V as well as from all of our member organizations and news about RISC-V out in the world. Public events and community events are both listed there. You can find links to those things. The member portal itself is on lists.risc5.org. This is the place where all of the working groups meet. It's a set of mailing lists. There are about 50 or 60 of them, so it can be a little bit difficult to navigate, but there is a guide that you can find in the community section on risc5.org. There is a wiki that we are just now starting to build out. It's at wiki.risc5.org. The technical space is actually the most built out space. And it's in constant motion, as every wiki is. You know, that's a good place to start if you want to dive into the technical world of RISC-V and the ISA development. The specs and the public mailing list are both listed on the website underneath the technical section. The specifications, I think Stefano will cover in just a few moments. The public mailing lists have been around for a very long time. They predate the RISC-V Foundation and RISC-V International. They're a great place to go and ask questions and to learn more about RISC-V as a technology. You can find more information there. There's also a link to, I think, Stack Overflow, and we've got a few other things that we'll be putting there over the next few months. Issue tracking within RISC-V is done using Jira. There's a link to jira.risc5.org. There is a shared Google Drive that we use for document storage. There are repositories that we use on GitHub, which Stefano will also cover because GitHub, a lot of our work is done using GitHub. We have an organization there. And then for Slack, we'll talk about that in just a few moments here. So the most important thing probably is the where to find help. So if you ever run into an issue where you need help in RISC-V, you can just send us a note at help@risc5.org. That comes to Stefano and myself, and we can redirect it to wherever it needs to go. So with that, I'd like to hand it off to my colleague Stefano, who can tell you a lot about GitHub and several other things.
Thanks very much, Jeffro. So hello, for those of you who don't know me, my name is Stefano and I'm a technical program manager with RISC-V. I'm going to start by going over GitHub, which is probably familiar to many of you. We've chosen this as a place to do work both in terms of our code development and the specification development. You'll notice that there is a group of people who are associated with our RISC-V organization. If you do need admin access to any of the repositories here, we'll create you an account as part of our org. And then we'll give you the appropriate permissions that we need. But anyone can contribute to these repositories. So being a member of the RISC-V org on GitHub is not necessary for contributions. And let's go over a little bit of the details about GitHub. So there is a policy document when we go over documentation about this. However, I just wanted to highlight some of the more important rules that I think we're trying to create as standard ways of using GitHub. So it might be obvious to many of you, but as sort of a rule of the road, no proprietary code is going to be allowed in our GitHub organization. The idea here is that we're an open source community, working on open source specifications. And if we do have any code, we'd like it to be open source. If for some reason we do need to reference proprietary code, that's perfectly fine. We just will link to those binaries or that set of code somewhere off of our GitHub repository. And this is pretty common in most open source communities. A couple of things that just as general guidelines, all of our repositories should contain. All of them should contain some document on how to contribute. It can be really confusing to newcomers to any project on how they can be effective and contribute. So by documenting this clearly, either in the README or its own file, it makes it easier for people to become involved. Obviously, we want to make sure that licensing is addressed in all of our repositories. And if you have questions, help@risc5.org is a great place to email in terms of what license you should be using. And we also want to call out who our maintainers are for a couple of reasons. First off, we're proud that we have these folks adding to our community, and we'd like to celebrate that. And then also, we'd like to make it obvious who to ask questions if there are questions specific to any given repository. If you're working on a task group, we'd like to have your charter available in the GitHub repository as well. That way it's very clear what the purpose of the task group is for. And that can be mentioned in the README, which is highly encouraged that each repository have a README. This makes it obvious as soon as you hit the repository of what the purpose of the repository is. So moving on specifically for specifications repos where you're developing either ISA specific specifications or non-ISA specifications, we need to limit who has right access to these repos. And as I talked about earlier, that's one of the reasons why we have members of the RISC-V GitHub org. So that will be a factor in these repos. Only specific people will have access to commit code. We prefer to use GitHub pull requests for all of our specifications. That way there's a very clear trail of how these specifications were changed. And we'd also like to use the issue tracking within GitHub. This gives us sort of a one-stop shop for all of the traceability of our specifications. And lastly, the documenting any errata should happen inside these repositories. We don't want to have to go somewhere else for that information. We'd also like to see nightly builds or builds for each commit on any specification. The idea here is that we don't want to make people have to learn how to generate PDFs. We'd like that to be done automatically for folks interested in consuming these documents. So moving on to software and firmware repositories, a basic rule of thumb is just to follow best upstream practices. If the code does have an upstream repository that it's going to be contributing to, be sure to read what their contributing documentation says, how they prefer to have pull requests or patches sent in, and please follow those rules. If you're not pushing to an upstream repository, please be sure that your rules are clearly documented so folks know how to contribute. In terms of staging code, we want to use branches for staging any code. So preferably, we'd like to have all these branches and any forks be public. So please do work with the maintainers of the repository to get those branches added. And then if you do have to fork internally, we'd like to remind our members that we do highly discourage that practice. We would love to have all the work done publicly, but we do understand that that is sometimes a necessary evil. So moving on to documentation, as Mark already mentioned, there are two basic types of documentation that you'll run into in terms of the work that we're producing. One of them are the instructions set architecture, the ISA specifications. You can find the latest documentation on our website, both volume 1 and 2, the unprivileged and privileged specifications. And there's also links on our website to the GitHub repos where you can find the nightly builds that are currently being compiled. But it's interesting and important to call out that there are also non-ISA specifications. So the debug, trace, compliance, and configuration specifications are great examples of that. These aren't part of the unprivileged or privileged specs, but they are available on the website, and there are links to the repositories where those documents are being worked on. All of our documentation and software is all held under the same GitHub repository, github.com/RISC-V. So that is the one place you'll need to go to find any of the working documentation that we're currently engaged in. The member portal. So the member portal has changed its role quite a bit, even since I've started. But a good way to think of this is it really is a replacement for what many of you have probably used as Mailman. It's a mailing list, a mail listserv, and that is its primary use today. So it sort of serves double duty. One is that it provides these mailing lists as completely open source, so that, completely open to the public. So all of the messages on our mailing lists are viewable by the public. However, for contributing to the projects, these only allow mail to come in from internal members. External folks can email these lists. However, those will be moderated. So the whoever is the moderator of that mailing list will see the message and respond to it appropriately. But the conversations are really driven by membership. And that is the main purpose. We did used to use this tool for calendaring and file storage, but we no longer do that. So you may see some remnants of that. Speaking of things that are new and exciting, we have moved to Google Calendars. So the calendaring program on the member portal was insufficient for our needs. So we moved to Google Calendar, and this seems to be working well. We have a main groups calendar that is open to the public. So anyone can see when we're meeting and when we're doing our work. The meetings themselves are for members only, and those meetings are under the auspice of the chair of that group. But you can very easily add these meetings to your calendar, whether it be a Google Calendar or an Outlook calendar, and there are instructions online on how to do that. In terms of how we meet, we use Zoom. The reason we settled on one platform was to just make it easier for our members to join meetings, to not have to have several different applications installed. It's much easier if we can just have one application on our phone and on our computer and know that that's the application we're going to use for our meetings. So we do use Zoom for all of our meetings. I mentioned that we at one point used the member portal to share files, but we no longer do. We now use a shared Google Drive. This is a drive which is shared and open for all to use, so all of our members have access to this. We are currently keeping our meeting minutes for both the technical steering committee and for the tech chairs in here, as well as lots of information, just general information on RISC-V. We have our all hands meeting as well. And you'll find the planning documents that we're using for our upcoming efforts in here, as well as policies. So if, for example, the GitHub information that I shared is all available in the GitHub policy, and how to write documentation has its own policy. So we highly encourage folks to go in there and just peruse the policies that make sense for you to be interested in reading and knowing more about. In terms of meeting minutes and status, we've recently decided to move those to GitHub. So our meeting minutes are all stored in GitHub. I'm using the CMOs group here as an example. So you can see that they have a GitHub repository where they're sharing a lot of information, and they have a folder specifically for their agenda and meeting minutes. If you have any questions about how to do this, how to take meeting minutes, what sort of things are okay to log and which aren't, please do send an email to help@risc5.org. We realize that taking meeting minutes and just running meetings in general is new to many folks. And so we're happy to walk you through what a good process is to follow there and sort of give you the best practices. Okay, with that, I'm going to switch over to Jeffro to explain more about Slack. But again, help@risc5.org for any questions on anything I mentioned. Back to you, Jeffro.
Thank you, Stefano. So let's talk a little bit about Slack. Slack, we have a Slack space, a workspace that has a number of different channels. The idea eventually is that we will have channels for most of the working groups, or whichever working group needs a Slack channel, and also Slack channels for each of the open source hardware projects that are on the exchange. We are also going to be rolling out sometime between now and January, we will be rolling out a new set of forums for the exchange. And so we'll have some more information on that as we develop it. Keep an eye out for announcements in the future on things like this. We also have a wiki that we have been in the process of building out. As you can see, it is not thoroughly complete yet, but it does have all of the important links that we link to for our technical work. You'll find links to copyright conventions, to the code of conduct, to ASCII doc, which is the method by which we develop all of our documentation, all of our specifications. There's a glossary of terms. There's a getting started document that's in progress, and a whole bunch of other links that go to various places, including to the calendar entries that Stefano just mentioned. And finally, we come to our Jira. Jira is an issue tracking tool. We use it for internal tracking as well as for items that are related to the development of the specifications. For issues that are related to the specifications themselves, we recommend that people go to GitHub issues in the GitHub repo for that particular project. That's really the best practice for that. And but otherwise, there are categories for each of the various working groups. And this is a great place to find out what's going on. back to you, Mark.
Hey, thank you very much, Jeffro and Stefano. That was great. Hopefully you all have learned a lot about what you can do to get involved with RISC-V and get off the ground quickly. As always, if you have any questions, help@risc5.org. But now I just want to talk a little bit about what you can do. So number one, this is the most important thing, develop products based on RISC-V. It's a very exciting technology. You know, again, started at Berkeley and really meant to last 50 years. It stands on the shoulders of all the processors that came before it, both RISC and CISC. So, you know, we've learned a lot. We're able to provide the technology that is the basis for this, you know, sort of grand movement into the future, this renaissance. We've had this renaissance in software and databases and everything else over the last 15, 20 years, and it's been fueled by the open source movement. This is the first open source computer chip of this magnitude that started in open source and wasn't gifted, you know, sort of later, and still has their sort of their founders totally behind it from a corporate perspective. This is totally a community effort. We feel pride of ownership. Everybody who I talk to is excited about RISC-V, who's working on it, and they feel proud of what they're doing with RISC-V. So if you aren't already a member of RISC-V International, please become one, either as a corporate member or individual member. There's information out on the risc5.org website, and again, help@risc5.org in case you have any questions. And then once you are a member, join the task groups and interest groups and help us get the work done. That's really very important. You know, evolving the extensions, figuring out what new extensions we need in order to help, you know, sort of industries that are emerging or that are important, that we can go ahead and help our members be successful in. And then again, the bottom of the iceberg, all these things that you know, they're basically all software that need to be done in order to make these extensions successful. So get involved. We're here to help. We're excited to present this to you today, and it's a call to action. Come join us. Thank you very much.